Is Anycubic's newly launched 3D printer the Kobra 4 combo that includes their new multi-material filament system a better value than Bambu Lab's A1 combo? That's what we're going to find out in this video. Hi, I'm Ken of Wrist Innovations, and welcome to today's video to take a peek under the hood of the newly launched Anycubic Kobra 4 Combo 3D printer and compare it to the Bambu Lab A1 combo printer. No, you're not seeing double. The Kobra 4 and the A1 look very similar. I'll cover the initial prints, features, unboxing, cost, and my final summary of both printers so you can make an informed decision on which model 3D printer you may want to consider buying. I have organized the video into chapters listed in the description that will allow you to skip around the video depending on what is important to you. I bought the Bambu Lab A1 combo with my own money. However, I want to thank Anycubic for sending me the Kobra 4 combo for my evaluation. Okay, let's get started. Let's first start with the most important part of evaluating a 3D printer, and that's the quality of the parts. I printed parts using PLA, PETG, and TPU, and I think you're going to be surprised at the results. First, I printed a preloaded design of a benchy in PLA on both printers. For the A1, the benching turned out overall very nice, as expected. For the Kobra 4, the benching turned out similar to the A1. Then I printed a filament waste bucket from the preloaded design. You can see there are some VFAs on the walls, but it will certainly fill the needs of a waste bucket. Next, I printed this calibration test design by Gabox 3D on printables using PLA. For the Kobra 4, the overhang test successfully printed all the way to 80 degrees, and overall it looked good. The various cylinder diameters measured 9.82 millimeters, 7.88 millimeters, 5.83 millimeters, and 3.86 millimeters versus design diameters of 10 millimeters, 8 millimeters, 6 millimeters, and 4 millimeters respectively. The various rectangle lengths measured 10.09 millimeters, 20.06 millimeters, and 30.05 millimeters for design lengths of 10 millimeters, 20 millimeters, and 30 millimeters respectively. Bridging overall looked good, and there were only a few stringers on the Kobra 4 part. For the A1, the overhang test also successfully printed all the way to 80 degrees. The various cylinder diameters measured 9.72 millimeters, 7.85 millimeters, 5.74 millimeters, and 3.75 millimeters versus design diameters of 10 millimeters, 8 millimeters, 6 millimeters, and 4 millimeters respectively. The various rectangle lengths measured 10.01 millimeters, 19.95 millimeters, and 29.97 millimeters for design lengths of 10 millimeters, 20 millimeters, and 30 millimeters respectively. Bridging overall looked good, and there were little to no stringers on the A1 part. The calibration test results were similar between both printers. We interrupt this program with a special report. Ken wants to find a way to quickly load and unload these wooden keychains into his laser engraver. So we thought, what about designing and making a special fixture for his laser engraver? He could design a laser fixture, but if he doesn't have a 3D printer, he could contact Justway, a company that he could send his design to and have them 3D print the parts for him. All he has to do is go on Justway's website, upload his STL file, and they would make the parts and ship them right to his door. Then, after Ken installs his laser fixture, he could easily load and unload his keychains into his laser engraver, and he would be so happy. If Ken needs other services in the future, such as CNC machining, sheet metal fabrication, and injection molding, Justway could help him with that as well. Now, back to your regularly scheduled program. Next, I printed a spiral vase design using PETG that was uploaded to printables by Max 413049. However, the original design is by Big Bad Bison on Thingiverse.com. For the A1, I used basic PETG and the vase turned out well. It did have some random defects, but overall it was a nice part. For the Kobra 4, I used Anycubic's PETG, and it also turned out well. There are a few stringers, but they were minor. It appears that both printers can handle PETG without any problem. Next, I printed this truck tire out of TPU designed by Elmcon 193290 on printables. Since TPU can be stringy, I dried the spool of TPU in my Sunlu filament dryer at 55 degrees C for 6 hours. For both the A1 and the Kobra 4, the TPU truck tires turned out great. I was impressed that there were little to no stringing on either part, and overall, they were of the same high quality. Even though I'm not a big fan of multicolor printing due to the amount of wasted filament and how slow the prints take, I was curious to see how the Kobra 4 compared to the A1. Of course, now everyone is talking about multi-head 3D printers, such as the Snapmaker U1, but not everyone has the budget for the higher priced printers. I decided to print a 4-color print in PLA of the Diphosphorus design by the Dragon's Den on MakerWorld. The A1 took 21 hours and 41 minutes to print the part, and it created 258 grams of waste. The Kobra 4 took 22 hours and 35 minutes to print, and it created 355 grams of waste. That means the Kobra 4 took about 54 minutes more than the A1, or about 3% additional time. Also, the Kobra created 97 more grams of filament waste than the A1, or a roughly 38% more waste. Now, I'm sure these numbers can be fine-tuned for both printers, but these were out-of-the-box results. Both printers produced a high-quality 4-color PLA print. So, to summarize the parts quality section of this video, based on my experience, the Anycubic Kobra 4 produced similar high-quality printed parts that rival the quality prints I produced from my Bambu Lab A1 printer. Now, let's cover the main features and the differences between the Kobra 4 combo versus the Bambu Lab A1 combo. The Kobra 4 has overall printer dimensions of approximately 460 millimeters wide by 460 millimeters deep by 600 millimeters high, but the combo requires an additional 370 millimeters wide due to the Ace2 Pro unit. So a total of 830 millimeters, while the Bambu Lab A1 combo has an overall dimensions of 680 millimeters wide by 410 millimeters deep by 620 millimeters high. Both the combo printers have a large footprint on the workbench due to the AMS Lite for the A1 and the Ace2 Pro for the Kobra 4. There is an upgrade available to mount the Bambu Lab AMS Lite to the top of the A1, but I'm focusing on the out-of-the-box experience with both printers. The A1 weighs 8.3 kilograms and the AMS Lite weighs 1.6 kilograms for a total of 9.9 kilograms, while the Kobra 4 weighs 9 kilograms and the Ace2 Pro weighs 4 kilograms for a total of 13 kilograms. The A1 print volume is 256 millimeters by 256 millimeters by 256 millimeters. However, the Kobra 4 print volume is slightly larger at 260 millimeters cubed. They are both bed slingers with an open design. Both printers have a maximum hot end temperature of 300 degrees C and a maximum build plate temperature of 100 degrees C. The A1 has a maximum speed of 500 millimeters per second, while the Kobra 4 has a maximum speed of 600 millimeters per second. Both printers offer quick change nozzle swaps in 0.4 millimeter diameter nozzles as a standard. However, Bambu Lab offers a 0.2 millimeter, a 0.6, and a 0.8 millimeter options, while the Anycubic offers 0.25 millimeters, 0.6 millimeters, and 0.8 millimeter hardened steel nozzles. They both have a nozzle wipe feature. Both the A1 and the Kobra 4 have multicolor filament multi-material capability. The A1 needs the AMS Lite, which offers 4 colors printing. However, you can connect up to 4 AMS units, which will allow up to 16 colors. The Kobra 4 needs the Ace2 Pro, which offers 4 colors printing. However, you can connect up to 2 Ace2 Pros, which will allow you up to 8 colors. The Ace2 Pro has some additional features compared to the AMS Lite, including the filaments are fully enclosed. The filaments can be actively dried even while printing up to 65 degrees C. And the Ace2 Pro has an automatic venting feature to allow moisture to escape from the unit. Both printers can recognize the RFID tags in their filament spools that allow their printers to recognize the color and specific material of each spool. The Bambu Lab AMS Lite and the Anycubic Ace2 Pro cannot be used with TPU, so in both cases an external filament holder will be needed. An external spool holder did not come with my Kobra 4 beta unit, so I used the spool holder from my Anycubic Kobra X. Anycubic told me that the external spool holder will be included with the Kobra 4 production units. They both come with a double-sided textured PEI build plate. Bambu Lab offers their Bambu Studio slicer, while Anycubic offers their Anycubic slicer, and they both offer their versions of phone apps to control their printers remotely. Both printers offer flow calibration and filament tangle detection. They both can print wirelessly using their slicers. They both have auto bed leveling, Z-axis offset, power loss recovery, and an external LED light. You can print the following filaments on both printers: PLA, PETG, TPU, and PVA. Both printers have a 3.5-inch color touchscreen to interface with the printer. You can transfer files using a USB drive for the Kobra 4 and a micro SD card for the A1. They both have built-in cameras. However, it appears that the A1 has a lower frame rate, so live feed is a bit erratic to watch, while the Kobra 4 seems to have a higher frame rate camera that has a smoother operation. Also, the Kobra 4 uses the camera for AI detection, while the A1 does not have this feature. Now, let's talk about unboxing and setup. It's similar to unbox and set up both printers, but for this video, I'm going to focus on the Kobra 4 since it's brand new. Once you remove the Kobra 4 from the box, it's just a matter of removing the various foam packaging from the printer. The accessory box contains the usual parts, including the power cords, Allen wrenches, etc. Remove the Ace 2 Pro from the foam. Cut the two large cable ties and remove the printer from the foam base. Remove the rear metal shipping bracket that is securing the platform to the base by removing 4 screws. Remove the front metal shipping bracket that is securing the platform to the base by removing those 4 screws. Install the front and rear covers. Remove the 2 Z-axis shipping brackets by removing 2 screws from each. Mount the tool head to the Y-axis bracket using 4 screws. Now to connect the Ace 2 Pro. Connect the 4-pin cable to the right side of the printer. Connect the 6-pin cable to the back of the Ace 2 Pro. Connect 4 Teflon tubing pieces to the back of the Ace 2 Pro and connect the other end of the Teflon tubing to the top of the tool head. Install the tubing management bracket to the right side of the gantry and route the Teflon tubing through the bracket. Install the power cords to the printer and the Ace 2 Pro and turn on both. Follow the screen prompts by choosing a language and follow the instructions. The printer will perform a self-inspection and then input shaping and auto bed leveling. Load some filament into the Ace 2 Pro. I also uploaded Anycubic's latest slicer software on my computer. Finally, I was ready to print my first part. One thing I like about the Kobra 4 is that it is almost entirely pre-assembled. I don't know if it's possible, but it would be great if the tool head was also pre-attached to the Y-axis so that a beginner wouldn't need to attach it. Also, for the production units, I assume a small installation manual will be included, similar to what Anycubic provides for other models of printers. The last thing I'll mention is that I was having a problem with changing filament types using the touchscreen, but I notified Anycubic, and within 24 hours, their engineering team provided a new firmware solution. So I was impressed with their response. Now, let's compare the cost of the Bambu A1 combo and the Anycubic Kobra 4 combo. At the making of this video, May of 2026, the Kobra 4 estimated pricing will be $199 and the Kobra 4 combo will be $299. As a comparison, the Bambu Lab A1 is on sale for $299, normally $399, and the A1 combo with the AMS Lite is on sale for $399, normally $559. So the Anycubic Kobra 4 combo will be approximately $100 less than the Bambu Lab A1 combo. Now let's go to my final summary. Overall, I'm impressed with the quality of the prints I made on both the Anycubic Kobra 4 and the Bambu Lab A1 printers. For a variety of materials such as PLA, TPU, and PETG, I consider the print quality to be comparable in quality. Both printers have a similar footprint due to their filament units, but the Anycubic Ace 2 Pro is an enclosed filament unit with drying features that the AMS Lite doesn't have. The Kobra 4 combo offers up to 8 colors using 2 Ace 2 Pro units, while the Bambu Lab A1 combo offers 16 colors, but you will need to buy 4 AMS 2 Pro units. The A1 print volume is 256 millimeters cubed. However, the Kobra 4 print volume is slightly larger at 260 millimeters cubed. Both printers have a maximum hot end temperature of 300 degrees C and a maximum build plate temperature of 100 degrees C. The A1 has a maximum speed of 500 millimeters per second, while the Kobra 4 has a maximum speed of 600 millimeters per second. Both printers offer quick change nozzle swaps and 0.4 millimeter diameter nozzles as standard. Both printers have their own slicer software and phone apps to control their printers remotely. They both have auto bed leveling, Z-axis offset, power loss recovery, and an external LED light. Both printers have a 3.5-inch color touchscreen to interface with the printer. They both have built-in cameras. However, the A1 has a low frame rate camera, so live feeds is a bit erratic to watch, while the Kobra 4 appears to have a higher frame rate camera that has a smoother operation. The estimated pricing of the Kobra 4 combo will be $299 versus the current sale price of the A1 combo of $399. So the Kobra 4 combo will be approximately $100 cheaper than the A1 combo. Although we don't know what the reliability will be of the Kobra 4, the similar features of the Kobra 4 combo to the A1 combo make it a budget-friendly alternative to the Bambu Lab A1 combo printer. What do you think? Which of these printers would you buy between the Kobra 4 combo and the Bambu Lab A1 combo? Let me know in the comments below. If you are interested in the Kobra 4, I do have an affiliate link in the description below. If you'd like to see my video titled New Anycubic Kobra X versus Bambu Lab A1, which is better? That link is here. If you'd like to see my video titled Anycubic S1 Max Best Large Format Value, that link is here. Thanks for watching. Bye.